Okay, this past week we've been working with squares, their side length, and their areas. And we basically determined that the area of a square, which is length times width, and because a square is a square, we also noticed that the area is side times side, or the area is just s squared. Just take the side length, square it to get the area. So to find the area of this square, as a review from what we've learned this week, you simply take the area is 13 squared, or what we know by now to be 169. So the area of this square is 169. Well, now we're going to kind of take it up a dimension and take a look at three-dimensional figures. And we're going to look at one specific type of three-dimensional figure, and that, of course, is a cube. So here I've got a picture of a cube. And like one thing that we notice about a square spectacles, all the sides are the same. Well, cube's kind of similar. All the edges of a cube are also the same length. Even though, visually this does not look like it's the same length as this front edge, it is mathematically the same length. So all edges of a cube are the same length. That's what makes a cube a cube. And now we're not going to be talking about area, because now we're going to be talking about volume. How much space is inside this shape? Well, to find volume, we would say length times width times height. Well, I just got done saying that on a cube, all the sides, well, let me actually label the length and width and height here. So it would be the length, this would be the width, and here we have the height. But like I just got done saying, all the sides are the same, so really this side, and this side are all the same length. So I can rewrite my volume formula as volume equals side times side times side. And if you guys can remember from what we talked about the other day, s times s times s can also be written as s to the third power. Or another way we call that is s cubed. So for this problem here with an edge length of 4, to find the volume, I would do 4 times 4 times 4, which is another way of saying 4 cubed. And 4 times 4 times 4 is 64. So the volume of this cube is 64 cubic units. Now, what we're going to take a look at are some cubes that you're going to have to memorize. The first few you should be able to figure out just by doing the math in your head, but maybe the last few you might have to spend a few minutes memorizing. But these are the more common cubes that you'll come across. So taking a look here at the second page, I have a cube up here in the top right corner, and we know that it's length, width, and height, which again, because all the edges are the same, it's just side times side times side. So if we have a side length of 1 here, that means all the sides or edges are 1. So my length, my width, and height would be 1 times 1 times 1, which another way of writing that is 1 cubed, and we just get 1, because 1 times 1 times 1 is just 1. So go ahead and continue taking these notes down as I go through them. I'm going to try to go a little fast here. So in the next one, if we have a side length of 2, it is just going to be 2 times 2 times 2, which is 2 cubed, and 2 cubed ends up being 8. Now, keep in mind, like we talked about the other day, 2 to the third power does not mean 2 times 3. It means 2 times itself 3 times. So 2 times 2 is 4, 4 times 2 is 8, that's how I get 8. Take a look at the next one here, side length of 3, so 3 times 3 times 3, which is 3 cubed. And this 3 times 3 is 9, 9 times 3 is 27. Okay, moving on to a side length of 4. 4 times 4 times 4, which is 4 cubed, or 4 to the third power, which is 64. Moving on to 5. And again, here's where it may be a little bit more difficult. These are the ones you're probably going to need to memorize. 5 is not too bad. 5 times 5 times 5, or 5 cubed. 5 times 5 is 25. If you had 5 quarters, you have 125. Moving on to 6. This is one that I definitely need to memorize here. 6 times 6 times 6. 6 to the third power. This is 216. And then finally, the last one you're going to need to memorize for the test on Monday is the 7. So 7 times 7 times 7, which is 7 cubed, and this is 343. So you can refer back to the sheet as we work through the problems. Now, that is to find the volume. You just multiply your length times your width times your height to get your volume. Now, like we did the other day, when dealing with squares, we had the area. How do we find the side length? Well, now we're going to look at something similar. Well, instead, we're going to be talking about the volume. So now we have the volume. We want to find out how long is the edge length. Well, now we're going to use a different radical sign. And here you can see the number 3's up there. This means the cube root. The little 3 tells us that we're wanting to find the cube root. And basically what you have to know is that this little symbol here is basically asking us a question. And the question is, what number times itself 3 times is the number inside the box? Let me show you what I mean. So here we have a volume of 8. So to find the edge length, I want to take the cube root of 8. So I need to ask myself, what number times itself 3 times is 8? Well, if you look on the previous page, you would see that it is actually 2. So the edge length here is 2, because 2 times 2 times 2 is 8. Same thing here. The cube root of 27. They give us the volume. To find the edge length, ask yourself, what number times itself 3 times is 27? Well, in that case, it is 3, because 3 times 3 times 3 is 27. Take a look at the last one here, 125, cube root of 125. Again, the more familiar you are with these numbers, the faster this goes. What number times itself 3 times is 125. That is 5. So the edge length, all edge lengths on this shape are 5. So let's just quickly go through the bottom part here to find the cube roots of all the following numbers. So again, ask yourself what number times itself 3 times is 27. That is 3. What number times itself 3 times is 8. That is 2. Again, you can refer back to the other sheet if you want. What number times itself 3 times is 64. That is 4, because 4 times 4 is 16. 16 times 4 is 64. Moving on. 7. 5, which you can see from up above. The cube root of 1. What number times itself 3 times is 1? Well, that's 1. 1 times 1 times 1 is 1. Cube root of 216. The cube root of 216 is 6. The cube root of 64 is 4. And finally, the cube root of 27. These guys are the popular ones. The cube root of 27 is 3. So finally, let's take a look at the last section here. This is probably the most difficult part. So here, just like we did with squares, in areas we want to estimate. So they're not perfect cubes. We want to estimate the value that the answers would fall between. So take a look at the first one. So the first one is not a perfect cube. The cube root of 20 we don't see in our chart, but we can estimate where does it fall between. So let's take a look here. 20 falls between 8 and 27. So that means the edge lengths must be between 2 and 3. So 2 and 3. Let's take a look at 200. So the cube root of 200 falls between 125 and 216. So I would say between 5 and 6. Notice I'm using my edge lengths for my answer because that's what they want to know. What is the edge length? So let's take a look at 100. The cube root of 100. Let's see, that falls between 64 and 125, which is between 4 and 5. So 4 and 5. Cube root of 150. Let's take a look at that guy. 150. You can see falls between 125 and 216. So 5 and 6. Almost done here. Cube root of 300. 300 right here between these last two guys. So that means it's between 6 and 7 here. So 6 and 7. And finally, the cube root of 4. The cube root of 4 falls between 1 and 8. So that means a side length or an edge length is going to be between 1 and 2. So let's take a look at the last section here. And again, it's very similar to what we talked about the other day with squares and estimating squares to the nearest tenth. We're going to be ballparking these. So what you're trying to find out, is it closer to the lower number or closer to the highest number, then make your estimation there. So let's take a look at an example. So the cube root of 12. So again, I want to find it to the nearest tenth. So 12 is going to fall between 1 and 8. And I can see it's a little, I'm sorry, not 1 and 8. Let me redo that. Back up. That's my reverse sound there. Not very good. So I'm going to find 12. 12 is between 8 and 27. And 12 is closer to 8 than it is 27, so my answer is going to be closer to 2 than it is 3, so I'm going to estimate something like 2.2. Take a look at 34, the cube root of 34. That falls between 27 and 64, and I would say that 34 is closer to 27 than it is 64, so I would estimate something like 3.3. Okay, if you had 3.4, you could argue for that as well, as long as you're within that ballpark. Here we have 300, so the cube root of 300, where's that going to go? That's going to go down here near the bottom. So that's between 216 and 343, so 300 is closer to 343, but it's almost in the middle, but it is closer to 343, so my answer is going to be closer to 7. So I want to say something like 6.8, 6.7, 6.8. Any of those would be okay. Take a look at cube root of 72. So 72 falls between 64 and 125. And 72 is pretty close. It's definitely closer to 64 than it is 125. So my answer is going to be somewhere closer to 4 than it is 5. So I'm going to say something like 4.2. Would be okay there. 190. So 190 would fall again between 125 and 216. And it is closer to 216 than it is 125. So my answer is going to be closer to 6. So I'm going to say something like 5.7, 5.8. I'll go with 5.7 here. And the last one, the cube root of 2. So the cube root of 2. Let's see here, it's between 1 and 8, and it is very close to 1, just barely above 1. So my estimation is going to be really close to 1, so 1.1 or 1.2 would be okay there. Okay? So go ahead and take the quiz. Try your best not to use the calculator. Feel free to use your notes for the quiz. And if you have any questions, feel free to ask your teacher. Thanks.